So in this question, I'm given this diagram and these bits of information here. I've got B, C and D are points on a circle centred at P. So B, C and D, they're on my circumference. The centre of that circle there is P. So I've got some form of quadrilateral here. Now, I don't know if this is halfway along this point D on this sub-arc here. So we don't know that information there. But I know this angle inside is Y. Now the other information I've got is that AB and AC are tangent to the circle. So these lines here coming along will form tangents to this circle. Now the angle formed by these two lines joining together is angle X. So we've got angle X and angle Y. What we want to do is to prove that Y equals 90 plus X over 2. So with that information, where are we going to go from there? Well, we can start using the information that we've been given. We've got AB and AC are tangent to the circle. So therefore, PC and PB, they are both radii. So let's write that down here. PC and PB are radii. Now, when we got radii joining a tangent, we know they form a right angle. So PCA and PBA, they will both be right angles. So therefore, with that information, PBA and PCA, they are 90 degrees. So that's one bit of information we've got there. So now we can get some sort of a quadrilateral. So PCAB and back to P, that will make a quadrilateral. And we've got right angle, angle X, and this angle here missing. So from that information, I can deduce that my angle BPC plus my angle X plus my two right angles, so plus 180 degrees, that will be the sum of the angles in a quadrilateral, which is 360. So that's 360. So I'll just write here, sum of angles in a quadrilateral are 360. So let's just write that there. So by sum of angles in a quadrilateral equal 360. So that's what statement we've got here. So let's put this one here in a little box. So that's what we've got so far. Now we've got another quadrilateral inside. Now this one here is a cyclic quadrilateral. So cyclic quadrilateral, what we've got is the angles inside still add up to 360. So sum to 360 degrees. Now with the angles that we've got and the information so far, I know that my angle BPC, so angle BPC plus this angle and this angle Y, they will also sum to 360. So plus angle PBD, let's just write that as angle BPD plus angle PCD. So that angle there plus Y, that also equals 360. Okay, now what I can also say with a cyclic quadrilateral is that this angle and this angle will be the same, and this angle and this angle will also be the same. So opposite angles also equal. So that's what we can say about our cyclic quadrilateral. Opposite angles equal. Okay, so BPC equals Y. So angle BPC equals Y. Now the size of these angles here, I don't know at the moment. So that's my next bit of information that I can put in there. So how am I going to find out what I've got here and what I've got in here? Now I know this angle here is found by this here. So let's use this angle here. So 360 equals 180 plus x plus angle BPC. Okay, now I want to try and find angle BPC. Now what I can see is that when you have two lines drawn from the centre of a circle meeting at a point, the angles which are formed from this angle here to this angle here will always be double. So therefore angle BPC will on its outer, so angle BPC, and then this will be on the outside, so we'll call that the major. So major, so that's the major angle because it's the larger part, BPC. This will be twice RY. So that's our angle, our theory there. So that's the angle there from the centre point to the point on the circumference. So if angle BPC is 2y, I can substitute 2y into this equation here. So 360 equals 180 plus x plus, I just missed the plus sign inside there, plus angle 2y. But this is not going to be 2y, this is going to be 360 minus 2y is the minor. So therefore angle BPC, the minor, i.e. the smaller part, this bit here, is going to be 360 minus 2y. So angles about a point are always 360. So just make a note here, angles about a point sum to 360. Okay. So my angle BPC, what I want there is my minor part, that's 360 minus 2y. So plus 360 minus 2y. Okay, so now I've got an equation with x and y, the same as I've got here, which I want to prove. So let's see if I can do something with that. So let's subtract 180 from both sides. So 360 equals 180, so that's 180 equals x plus 360 minus 2y. Okay, right, let's get this 180 on this side and then we'll bring the 2y over to this side. So now my 2 minus 2y becomes positive 2y and that equals x. 360 minus 180 gives me 180 and that would take care of that so far. Okay, now I've got an x over 2 here and an x here, so let's divide everything by 2 and then I'll get a y on its own as well. So then I'll have y equals x over 2 plus 90. And that then proves that we've got y equals 90 plus x over 2. So I could just rearrange that to get the 90 on this side and we'd have the equivalent term. Okay, there we go.